Hello, welcome to Crystal Core Skills. In this video, I am going to teach you how to make your own mask by applying simple concepts in mathematics. And the concept that we are going to look at is geometry. Geometry is the study of shape, size, surface, and position. According to geometry, a line can be defined by 2 points. So if you have one point on the left and the other one on the right, joining those 2 points form a line. Geometry also tells us that any line segment can be extended infinitely to either of the direction. That is to say, left or right, you can extend the line endlessly. You can apply the same principle in describing the particles in the air, the motion of the particle. For example, a point on the surface can symbolize a particle, and the movement of that particle can be modeled as a line. So a line can be used to demonstrate the movement of the particle in the air. Geometry also teaches us that a circle can be used to define any angles, and we know that circle is an enclosed surface with 360 degrees of the angle, so all around the circle is enclosed. Now we can apply this principle to describe the problems associated with mask, the solution to the problems, the design patterns, and the implementation of those designs to build the mask. By the end of this video, you will have learned how to design, develop, and deploy a secure face mask. One of the most common problems in making mask is the design. Design is one of the problems in most of the engineering activities, because once you get the design wrong, the entire product may be rendered useless or not secure. For example, take a look at this diagram. I've modeled the mask as the triangle here, the rectangle, not the triangle, the rectangle that you are seeing here. And the oval shape inside the rectangle is the position of your mouth and nose when you are covered with this mask. And the strings are attached to the side of this rectangle, and these strings are or can be held into your ear when you're putting or wearing this mask. Now the thing is, when you're wearing these strings, you have 2 sides of the string attached to the mask, and the string can form like some kind of like a shape here at the end where you put on around your ear, and that shape can form some sort of like an arc of a circle. And we know that according to geometry, an arc of a circle subtends an angle in the circle. So those 2 strings holding that shape in the ear can be modeled as the radii of the circle. Even if you don't see the circle there, just assume that the circle is there, because we have 2 ends of the string attached to your ear. Now the problem is that an arc of the circle will subtend an angle. Now that angle is a problem, and is a design problem, because they will provide a loophole for the air to come through and you breathe in. So if that air is from an infected person, then you're likely to get infected, and the airflow is represented by the arrow there. So that is the design problem we need to solve. The second problem is the type of the material used to make up the mask. So the mask may be made out from the materials that may not be geometrically correct. For example, the material may have some surfaces that may contain some particles which may be detrimental to your health. So breathing in those particles may cause some health issue either in the short run or in the long run, depending on the severity of the particles. Also, you need to be able to maintain and use the right techniques of putting on the mask, taking it off, and being able to maintain it when you are using it. So these are the problems that are very hidden, but they are really very serious problem. So in this diagram here, you see I have modeled a mask by forming a rectangular shape, and the arrows are showing the direction of the airflow, and then on the side of the rectangle you have the strings attached. So these are the strings that may cause problem when you put them on your ear to hold the mask in position, because the string will be creating some tensional force, and the side of the string may be modeled as the radii of the circle. So when you put on this string by forming this kind of an arc or a half of a circle, you are creating some kind of radius, because an arc of a circle subtends an angle in the circle. So those angles are the representative of the gaps that we may have on the mask. So those gaps provide loopholes for air to penetrate through, and if those air are coming from the infected source or person who might have been infected, then the user of the mask may get the problem as well. So the user may be infected. Now this is the solution that we may come up with. We need to come up with a good design. So a good design contains a circular kind of string that goes all around the head or the neck, connecting to the mask, which creates the tension all around the mask, and that will block any angles or any air coming in from an infected person. So this is the best design that I came up with. I referred it to be known as armed protection, which means all-round protection, all-round mask protection, because it provides 100% total protection when you use circular string that will not create any angles or any possibility for the air to come in. So how do you design this? Just take a piece of cloth, measure it accordingly, and then decompose it into smaller rectangles. For example, I decompose the original rectangle to many rectangles, and from here we need to manipulate these rectangles and create one rectangle from it, and the main focus is on the middle rectangles. The middle one, we need to make one rectangle, and that will become our mask. So how do you do it? You just do it by folding the long sides of the rectangle first on the middle one, and then that will lead to this long rectangle. So from here you need to fold the sides of the rectangle and form the middle one by just folding this one on top of that one, and then folding that side on top of this one. But when you're doing that, you need to create some sort of triangle at the end of either of the two rectangles on the side, so that one can go inside the other, and then you flatten it on the middle one to form our rectangle that we need as a target for creating the mask. After doing that, you will end up with this shape here, and this is our design pattern. This is the core design pattern that we need to achieve. The vertical lines and the horizontal lines are indicating the position of the strings. So in this case, to come up with a secure mask, we are going to have a circular string instead of having just a half circle or an arc of the string on the side. We are going to have a circular string throughout, and we're going to put that string inside this rectangle, and then that is it. We are done. like this. So when this circular string is put inside this mask here through the internal part of the rectangle we have created, because this rectangle is an hybrid of many rectangles, so we have a hole there. So you can push this circular string inside there so that you have a half of the string up and a half the string protruding down there, and then you hold the two ends together towards you and then push that rectangle outwardly to create a space in between where you push your head into where the mask. So this is the design pattern, and this is the secure mask that we want to achieve, and it will look something like this. So this is it. We have created a mask 7 by 10 centimeters with the string covering all around our head, our neck, and creating no space for any air to come in. So this is the design which I refer to as an arm protection mask, which is very secure, flexible, easy to use, scalable, and cost effective. At the end, you will have something like this, and you will have one for your mouth and nose, one for the other side of the ear, and one for the other, so that you have absolute protection for your ear, your nose, and mouth. For your eye, you can just get a spectacle and put it on so that you have absolute protection. So this is it. If you have this in place, you will be protected. And that is it. This is the overall design that we have gone through. You start by doing the measurement and decompose it into smaller size, and then do the folding for the first one to gain this long rectangle shape, and then folding the two sides you get the middle rectangle and obtain this pattern, and from this pattern you just put our round string there to create our target mask. From here you can actually abstract different kind of design patterns to create a different kind of mask that you may want. But what you need to know here is that at each level of abstraction you will experience a different level of complexity as a result of additional features that you may need to create a new design pattern. So those features may increase the cost, and obviously if you can afford it, it's good, as long as you have this round circular string to maintain and keep you safe, that's fine. So this is it. This is the best way to design a mask for you, a secure mask for your family. If you're a business owner or you're a small business startup, you can apply these techniques and apply these patterns to mass produce the mask. Thank you for viewing, and I hope this has been informative to you, and I'll see you in the next video, in which I will be demonstrating how to actually make this mask. Please don't forget to drop any comments. Your feedback is very important, and I like constructive criticism, because through criticism I learn, because we learn by making mistakes. Thank you.